Namaste and welcome. Today I'm going to expose the great British elementary maths scandal. I'm Jonathan Crabtree, founder of Podomatic Bhatia Maths. When I was age 7, I argued with my teacher about her explanation of multiplication. I later read it was centuries old. I thought the multiplication explanation was wrong. My teacher, Miss Collins, said multiplication was just repeated addition. She wrote 2 multiplied into 3 and asked, who can tell me what 2 added to itself 3 times is? I put up my hand and said 8. Yet she insisted it was 6, which I knew was wrong. So here we are, 1968, my class photo. There I am sitting at the front, and there is my teacher, Miss Collins. When I was 21 years old, I promised to change the way the Western world taught maths. Now I'm 61 and finally ready to share some of my detective work. I'm here today not in the world of academia. I'm here in a court of public opinion to bring about class action in K-8 maths education. The High Court of Common Sense and Public Opinion. It's Jonathan J. Crabtree, the plaintiff, your presenter, versus the United Kingdom of Great Britain and Northern Ireland, the British, as the defendant. 500 years of broken British maths. Here we are in the matter of the negligent abuse of power by the aforenamed defendant to suppress, deny, and delay the adoption of India's superior zero-based foundations of elementary K-8 level mathematics between 1522 and 2022. The statements of claim. Section 1. The British have failed to divulge the simple symmetric nature of India's original definition of zero. They've failed to divulge the correct concepts of the 4 basic operations of addition, subtraction, multiplication, and division. They've failed to divulge the true nature of negative and positive numbers with regard to Section 1, 0, and Section 2, operations. The Great British Elementary Maths Scandal, Part 1. The laws of elementary mathematics kept from us. Point 4. Relating to the definition of zero at Section 1, Brahmagupta's Brahmaspita Siddhanta, 628 CE, he has written Sanskrit shlokas from chapter 18. The Addition Sutras, Addition Sutra number 4. When positive and negative are equal, the sum is 0. 5 negatives are greater in magnitude and multitude than 2 negatives. Subtraction Sutras, Subtraction Sutra number 3. Positive 7, or 7 positives, minus 4 positives equals 3 positives. So Subtraction Sutra number 3 says that when you subtract less from greater, the sign of the answer stays the same. And yet when you subtract greater from less, the sign of the subtraction changes. So here you can see that we've subtracted 4 positives from 7 positives, and the sign is the same, with the answer being obviously 3 positives. And here we've got 4 positives minus 7 positives being greater than 4 positives, and so the sign of the answer changes to 3 negatives. We have 5 negatives minus 2 negatives equals 3 negatives. So from the logic and laws of India, 2 negatives are obviously less than 5 negatives. So the sign of the answer does not change. And yet if we've got 2 negatives, or negative 2, minus 5 negatives, or negative 5, well, guess what? 5 negatives are greater than 2 negatives, so the sign of the answer changes. Now, straight away, the British are responsible for telling us that somehow 2 negatives are greater than 5 negatives, but 2 of anything is not greater than 5 of the same thing. It's absurd, has been for centuries. It's got to go. The Sanskrit multiplication sutras, which are the laws of mathematics kept from us. And we'll just quickly move on to division. There they are in the Sanskrit. There they are in the English. Section 12.12 states that negative and positive quantities are equal and opposite and symmetric about 0. So here we have a conceptual number line of B lines named after Brahmagupta for basic numbers. These basic numbers describe equal and opposite units of negative and positive. And you can see that as we move to the right of 0, the distance on the line gets greater and the count of units also gets greater. Similarly, with the left, as we go further from 0 to the left, the distance of the line gets greater and the count of the quantities also gets greater. The least number and the least quantity in this diagram is shunya, which means 0. And here we've got section 14.14, a representation of Brahmagupta from 628 CE by my friends in Kolkata, AFX Animation. Section 15.15, negatives and positives are either added to 0 or subtracted from 0. Negatives and positives of equal magnitude or multitude can cancel each other out to 0. And the least quantity and the least number is 0, not negative infinity. So numbers represent counts or measures of quantities and actions or operations. And the least number of actions or operations is 0. All additions yield the same number regardless of the order of addition. All subtractions yield the same number regardless of the order of subtraction. When less is subtracted from greater, the sign of the difference remains the same. So from 5 positives, subtract 2 positives and 3 positives remain. From 5 negatives, subtract 2 negatives and 3 negatives remain. So 5 negatives minus 2 negatives equals 3 negatives. When greater is subtracted from lesser, the sign of the difference changes. From 2 positives, subtract 5 positives, we have 3 negatives remain. This is subtraction sutra 3 kicking in. We're subtracting greater from lesser, and that's why the sign has changed in the answer. From 2 negatives, subtract 5 negatives, and 3 positives remain. So the larger number is subtracted from the smaller, the sign changes, so 5 negatives are greater than 2 negatives. We've got a positive minus a lesser positive equals a positive. We've reversed it. We've got the smaller positive minus a larger positive, and the law of subtraction, Sutra 3, says that when that happens, we change the sign. But look at the numbers. The numbers remain the same. It's simply the sign that changes. We can start to separate out the basic numbers when we understand all they do is count or measure equal and opposite units. And here we see the numbers remain the same regardless of the order of subtraction. All that happens is that the sign of the answer changes. We'll do it again. 94,085 minus negative 52,401 equals positive 146,486. Got negative 94,085 minus 52,401. We're subtracting different signed numbers now, but have a look at what the numbers are the same. And when we understand the subtraction sutras of Brahmagupta, we'll see exactly how all of this can work. And it's really years earlier that we can teach this. The numbers are the same. We just have to understand how the sign changes, and that's what India explained, and the West has never gone into this level of detail. So equalities and inequalities are determined by the number of the multitude or magnitude and not the sign of the multitude or magnitude. If you look down the left-hand side, we've got positive squares and we've got negative squares. And we just look at the counts, the visual quantities, and we can see that this number of black squares is greater than that number of red squares. So let's have a look at how this works out. What numbers, we're looking at the numbers, are greater? Well, we can cancel out the 5 red positives against the 5 black negatives, and we see there are more negatives, so what happens is we have 2 negatives remaining. So 5 positives are absolutely less than 7 negatives. And you can see I introduced a new simpler absolutely less symbol there. We cancel out the 4 positives and the 4 negatives. We see that the 5 positives remain, so 9 positives are absolutely greater than 4 negatives. Here we see we can cancel out 1 positive and 1 negative, and we see that the remainder are negative. So 1 positive is absolutely less than 3 negatives. And here we see that we cancel out everything. In this one here, we cancel out 5 positives and 5 negatives. So we say here 5 positives are equal and opposite to 5 negatives. So we've got 2 new symbols on this page, the equal and opposite symbol and the absolutely less and absolutely greater than triangles. Let's now start to look at the inequality symbol, and we can see how the absolutely greater and less works when we put the quantities inside the conventional inequality signs. So here we've got 1 positive and we've got 3 positives, and we can see from the image 1 positive is absolutely less than 3 positives. What if we go over to the fourth one here and we go 3 negatives are absolutely greater than 1 positive? Have a look at the ideogram and it shows you the logic. Here we've got 3 positives are absolutely greater than 1 negative, and so on. Have a look at this diagram. We can see that 2 positives are equal to 2 positives. We can see 2 negatives are equal to 2 negatives. And we can see here in this bottom left diagram that 2 positives are equal and opposite to 2 negatives. And there's the way that we might write that with the new equal and opposite symbol. You cannot subtract what you don't have. It sounds pretty basic. An example of mixed sign subtractions, 5 positives minus 7 negatives. We have 5 positives minus 7 negatives. It can't be done as we don't have any negatives to subtract. Can't be done. What we do is we add 0 via addition sutra number 5. So let's add a 0. So here we've got 1, 2, 3, 4, 5. We've got 7 negatives and 7 positives, which we can add to this initial quantity. So now we can subtract the 7 negatives. So now we can do this subtraction, and as you can see in the diagram, it leaves 12 positives, which is why 5 positives minus 7 negatives equals 12 positives. Point 26. Via the basic symmetric numbers of Brahmagupta at section 13, either positive or negative units, which I more precisely describe as pronits for positive units and opponits for negative units. Negative is not a good word to deal with mathematics and our growth mindset and belief system. So let's get rid of the, for children, under podometic Bharatiya maths, we have units as the meta concept, and then we have pronits and opponits for positive and negative. Now they can be repeatedly added to or subtracted from 0. Now, point 27, with basic multiplication, the positive and negative symbols in front of multiplicands, the number of units, either pro or oppo, are either added to 0 or subtracted from 0 according to the plus or minus sign of the multiplier, which acts as an operation counter on basic numbers. Due to the suppression of India's 0 by the defendant, -1 multiplied into -1 equaling +1 is taught via abstract laws, not common sense, years too late. And here's a typical presentation of how you might prove the result. So let's dive into the detail, which is what the West has never understood. We have a negative multiplicand multiplied into a subtracting multiplier. So the symbol before the multiplicand is here, it's negative, and we have a minus sign in front of the multiplier, so it involves subtraction from 0. And so we can see here, negative a subtracted from 0 b times. That's what that expression actually means. So we take the example of -1 multiplied into -1, or more correctly, -1, and it's -1 subtracted from 0 one time. As we now know, Brahmagupta defined 0 in Addition Sutra number 4. When positive and negative are equal, the sum is 0. So let's have a look at a visual, intuitive, common sense proof. So here in the circle, the 0 circle, we have one positive and one negative, and they are, by definition, combining as a 0. We know that -1 multiplied into -1 means -1 subtracted from 0 one time. So there's our 0 in the green circle. Let's subtract the -1, and there it disappears, and we see that +1 or 1 positive remains. How simple is that? That's a concept that we can introduce probably in class 2 or grade 2 rather than wait for another 5 years. So therefore, -1 multiplied into -1 equals +1 or 1 positive, as I prefer to say. Here it is again, nice and big. I want you to really take this in. That's a 0 because we have a pair of equal and opposite quantities or numbers. So -1 multiplied into -1, -1 subtracted from 0 one time equals 1. There's your answer to that result. What about -2 multiplied into -2? Well, it's simply -2 subtracted from 0 two times. So there we've subtracted, -2 is subtracted from 0 one time, and that equals 2 positives, or +2. And we've subtracted, -2 is subtracted from 0 two times, and that equals 4 positives. In this, the Great British Elementary Maths Scandal, we now move on to part 2. The 500 years of broken British maths, the 0 assassins. Let's meet them. First off, we have the priest Cuthbert Tunstall in 1522. He wrote a book, The Art of Calculation, in 4 books. It was published in October 1522, 500 years since the British began breaking the foundations of mathematics. In this book, 1522, 0 was a placeholder only. Cuthbert Tunstall refers to Pythagoras, who flourished around about 530 BCE, and Aristotle, and also refers to Euclid as well. But there's no mention of Brahmagupta, whose ideas were 900 to 1,100 years more modern. Tunstall copied ideas from Luca Pacioli's book, The Sum of Arithmetic, Geometry, Proportion and Proportionality, that was published in 1494. And Pacioli got his ideas from Piero della Francesca, and in the book Trattato d'Abaco from 1470, Della Francesco got his ideas from Leonardo Pisano, also known as Fibonacci, from the year 1202. So there's been, in a way, a lot of copying of other people's ideas, but not a whole lot of originality compared to the breakthroughs, the huge breakthroughs that were made in the Indian Golden Age. Pisano, to continue that chain, got his ideas from Al-Khwarizmi's book, The Book of Indian Calculation, which was published around about 820 CE. Al-Khwarizmi did not get the correct definition of 0 and how it operates with negative and positive quantities from Brahmagupta's Brahmaspita Siddhanta of 628 CE. Let's have a look at the Arabic authors who didn't understand India's laws of zero. So when the mathematics of India went to the Middle East and to Iraq in particular, none of these Arabic authors on Indian mathematics understood India's laws of zero or its definition. So when it got to Al-Khwarizmi, he didn't understand zero as being a sum of equal and opposite, negative and positive quantities. When it went into North Africa, where it was discovered there by Leonardo Pisano, same thing, didn't understand it. When it went to England and it got to Robert Recorde, who was the most influential of all of the mathematics writers in the 16th century, didn't understand it. So those unaware that zero was defined as a sum of equal and opposite, positive and negative, were Robert Recorde, then before him Leonardo Pisano, Fibonacci, then before that the traders in North Africa, and before that Al-Khwarizmi. I invented the sign equals and introduced the pre-existing sign plus to England, says Robert Recorde. I never knew your zero definition, Brahmagupta, or your 18 sutras for zero, positives and negatives. And then the British Empire exported bad mathematical foundations to all its settlements and colonies. And as the English language spread throughout the world, so too did bad English ideas. The British broke the foundations of math. So we move on from Cuthbert Tunstall to Robert Recorde, 1543. And he wrote the phenomenally successful The Ground of Arts. And in this book, zero, the cipher, was again a placeholder. That's all it was. It was like a punctuation mark to put the numbers into the correct columns. There was no hint of Indian symmetry of equal, negative and positive summing to zero. Now, it was a popular book for teaching arithmetic of positive whole numbers, counters and finger reckoning. By the way, this book was published right up to the 1699, so it was published for 150 years. This book was out there dominating the British understanding of arithmetic. No hint of negative numbers or any of the simple ideas I've explained that should have arose. Now, in a later book, The Whetstone of Wit, published in 1557, Robert Recorde created and used an equals sign and also made the pre-existing plus sign popular. So the British started to dominate the symbols that we use today, but they did not dominate the true concepts of the foundations. So they put a symbolic set of symbols on top of faulty logic. I will read this passage. Indeed, they, the ciphers, are of no value themselves, but they serve to make up number of places, and so maketh the figure following them to be in a further place, and therefore to signify the more value, as in this example 90. The cipher is of no value, but yet he occupieth the first place, and causeth 9 to be in the second place, and so to signify 10 times 9, that is 90. You can see how they still had to use Roman numerals in their explanations, because these Arabic numerals, as they were known, even though they were truly Hindu in origin, so we can see, so that is 90, that is 2 ciphers, thrusteth the figure following them into the third place, and so on. So we move on to Henry Billingsley. Henry Billingsley brought out the first English edition of the circa 300 BCE Elements of Geometry. And here you can see the start of Book 7, which is all about the number theory of line segments. 1 was a unit, not a number. A number was defined as a multitude of units. So under the foundations that the British took to heart, 1 wasn't a number, and numbers started at 2. So much for 0 and 1, which powers the computer and the phone that you're using. The British in the 16th century said they weren't numbers. Now, as you'd expect from an ancient Greek geometry text, There was no arithmetical concept of zero or negative numbers anywhere, and this was a geometry text, yet people morphed Book 7 on the geometry of line segments into arithmetic. The book forever made multiplication be taught as repeated addition. So this was the start of the dumbing down of elementary mathematics. We move on to John Dee. Dee wrote a mathematical preface for the public that became his most famous work, and this preface appeared in Henry Billingsley's English edition of Euclid's Elements, which was big news. So John Dee was actually responsible for the change in Euclid's definition of multiplication. He made Billingsley insert the phrase added to itself, which had never appeared before in any translation in any language. And I've checked this in close to 20 different languages, from ancient Greek, Latin, Sanskrit, Hindu, Arabic, Hebrew, French, German, Italian, Russian, Dutch, Czech, Spanish, Mandarin. Euclid's multiplication definition says placed together in the Greek and the Latin, not added to itself. So across the top of the page, that's actually how the definition appeared. And the faulty multiplication definition appears as a number is said to multiply a number when the number multiplied is so oftentimes added to itself as there are in the numbers multiplying unities and another number is produced. Now, the basic problem is that the Greek geometry of 300 BCE, they didn't have zero, so when they were translating the geometry into the arithmetic, they couldn't use the number zero because it wasn't something the Greeks had. And if you can't use zero, you can't add a number onto zero to start the multiplication. And so they just said, well, we'll add it to itself. And zero was the realm of the devil, it was the void, and so the Christian church was against it and any idea that there might be an infinity, because obviously God is the only thing that's infinite. Here's a very important point. Euclid never mentions addition in any Book 7 proposition or proof using multiplication. I draw you back to my question in class 2 in 1968. Who can tell me what 2 added to itself 3 times is? Well, 2 added to 1 3 times is 7. 1 plus 2 plus 2 plus 2. That's 7. So 2 added to itself 3 times is 2. Plus 2 plus 2 plus 2. That's 8. And that's the problem I had with my teacher. She didn't understand that. She showed it on the number line, but as she did 3 hops of 2 on the number line, she started at 0. And yet the definition she quoted in 1968 in class 2 was added to itself. So you can see this link here. That'll take you to lots and lots of research and pictures as well. So even though Euclid never mentions addition in any Book 7 proposition or proof using multiplication, we look at this definition of multiplication, which is a screenshot from today, the 2nd of October, and we see here A multiplied into B, AB, by which the product of 2 quantities is calculated. To multiply A by positive integral B is to add A to itself B times. Now, according to this definition, 1 multiplied into 1 equals 1 added to itself 1 time, which equals 2. So if we follow this definition according to its structure, it fails. 1 multiplied into 1 equals 2. And what we know is that it should have been fixed hundreds of years ago, but it wasn't because, well, as I'll read this here, the definition of multiplication has remained wrong since 1570 because people thought it was Euclid's. If Euclid was a giant of mathematics and geometry, we'd not dare change his definition. Now, had people known that it was an invention by John Dee and Henry Billingsley, it would most likely have been fixed centuries ago. They would have demanded the original words be translated of Euclid, which were placed together. If we then put placed together into the definition, 2 multiplied into 3 becomes 2 placed together 3 times. So that's simply 2, 2, and 2, which is 6. It fixes everything. So we move on to William Oughtred as another of the British zero assassins. William Orchard created the multiplication symbol and the proportion symbols we use today. And we can see a correct concept of multiplication here from his English edition. As 1 is to either of the factors, so is the other to the product. As 4 upon 6 makes 24, therefore we can see the proportions. As 1 is to 4, so 6 is to 24. And as 1 is to 6, so 2 is 4 is to 24. And you can multiply the inners. 4 times 6 equals 1 times 24, and so on. So Orchard had the correct ideas of multiplication as a proportional relationship, which becomes very simple to teach, by the way. But unfortunately, it didn't help anybody out. Now, he also invented an early version of the mechanical slide rule used for calculation. So congratulations. But here's one of the problems, and where are the areas of confusion. Via Orchard, this cross symbol here, upright cross, and the dash symbol came to serve two different roles as verbs and adjectives. As plus and minus verbs, the symbols mean plus and minus, and as positive and negative adjectives, the cross and the dash mean positive and negative. So people have forever been confused between a symbol, does it mean negative or does it mean subtract? So in my way, and as others have done from time to time, if we use the superscript signs for positive and negative, and we can use the normal case signs to mean plus and minus. And then as you've been seeing in my numbers, it becomes a lot easier to read the grammar of the mathematics. So if we ask a question, what does minus 7 minus 4 equal? That's almost impossible. How on earth do we decipher that? Now, for clarity, if we have 7 negatives minus 4 negatives, well, that's obviously, to children, 3 negatives. We can start to read expressions correctly. So here's a problem with William Orchard, though. He was one of the first to say that negative numbers were less than 0. So as I quote, and it is to be noted that a negative number, how great soever, is less than every, both affirmative, meaning positive, and lesser negative, as negative 4 is less than 1 and less than negative 1. So today we're taught that 4 negatives are less than 1 negatives because this zero assassin, William Orchard, great with symbols, great with logic, many other things, but he didn't understand that 4 of anything has to be greater than 1 of the same thing. It's also contrary to common sense and laws of physics such as Newton's third law. Every action has an equal and opposite reaction. We move on in the Zero Assassins to John Wallis. And John Wallis, if we look here, he says negative quantities import a quantity less than nothing. And he presented a line in which a move leftwards 3 yards from A to D, so moving from A to D, was less than nothing. And you can see here in this story, which you can read later on, a movement from here to here, John Wallis says that the man has marched and advanced 3 yards less than nothing. And this became the basis of our modern illogical number line, where the further left you go, for some reason, the lesser the quantity and the number, even though the quantities get bigger of opposite units and the numbers get bigger as well. This was because the line only had one direction to the right, only one arrowhead. If we think about it, what was in John Wallis's head, he only wanted to move right or eastward, and moving the opposite direction was in a wrong direction for John Wallis. But today we're still told that negatives are less than 0, even though our number lines now have 2 arrowheads. 2! We have a symmetric number line with 2 arrowheads. We really need to bring back the symmetry of India's mathematics if we're doing that. We also realize that once we get to the complex plane, the simple integer ordering disappears. So we move on. We skip right forward to Thomas Heath, 1908. Heath was a civil servant. He wanted a knighthood. And might I just remind people who are familiar with history, Henry Billingsley was knighted. He gained so much fame as a result of translating Euclid's Elements into English. Yes, he eventually became Sir Henry Billingsley, the man most responsible for the breakdown of the British understanding of arithmetic. Thomas Heath knew that the definition of multiplication that entered the English language in 1570 was false. Thomas Heath wrote thousands of words explaining the definitions that Euclid gave in Book 7. Yet, for the definition of multiplication, this is the well-known primary definition of multiplication as an abbreviation of addition. And he gives some clues in his book, and if you look at the clues, you see, he does not want to embarrass the Crown. He does not want to embarrass the British Empire by revealing that they've been quoting an absurd definition that makes no sense for hundreds of years. So Thomas Heath kept the secret, yet rather than reveal the truth, he remained silent, and a year after his translation of Euclid's Elements was published, he became Sir Thomas Heath. We have the payoff. He was silent. He didn't embarrass the royalty. If he had revealed the truth, he perhaps would not have received his knighthood, because the great embarrassment would have been revealed to the world. Let's move on to modern times, and let's look at professors from different backgrounds who have had their thinking infected by the virus of British mathematics. So we look at the book by Professor Stephen Strogatz, The Joy of X, in 2012. On a chapter titled Commuting, we read, "These humbling sessions have prompted me to revisit multiplication from scratch, and it's actually quite subtle once you start to think about it. Take the terminology, does 7 times 3 mean 7 added to itself 3 times, or 3 added to itself 7 times? Now, 7 added to itself 3 times equals 28, and 3 added to itself 7 times equals 24. So his own definitions that he uses don't compute, and they don't commute. So I did contact the professor after his book came out, and he did write back, and he wrote via email, "Hi Jonathan, I take your point. The colloquial phrasing, if interpreted literally, would give the wrong results you mention." And he goes on to say, "I agree that it's not literally correct." And on Twitter, he ran a poll about this, and he asked if other people had thought about this as well. And on Twitter, he says that this professor, I never thought about it before. So people have been using the added to itself phrase since 1570. When I do raise it with people, they do admit their mistake, and they are confident, and they fix their mistake. So if these great mathematicians can admit that they have been misled, as hundreds of thousands of others have, then we have hope. Let's go to another victim of the British virus, Professor Hangzhi Wu. In his book, Understanding Numbers in Elementary School Mathematics, and Professor Hangzhi Wu is one of the people behind the Common Core State Standards, and he writes, the product 3 multiplied into 5 could be defined equally well as 3 added to itself 5 times, but we have chosen to use the other convention instead, 5 added to itself 3 times. And also in the book he says, what is 17 multiplied into 12? By definition, this is 12 added to itself 17 times. Professor Hangzhi Wu is a very eminent mathematics education professor. He's just wrong. 3 added to itself 5 times equals 18, and 5 added to itself 3 times equals 20. So let's just pause. 5 added to itself once is 10. 5 added to itself twice is 15, and 5 added to itself 3 times is 20. So it's so obvious It's been hiding in plain sight, but professors haven't noticed. But they admit the error as soon as I point it out. And 17 multiplied into 12 equals 204, but 12 added to itself 17 times equals 216. Now, I contacted Professor Wu, and he published corrections based on my feedback. He released an errata, which is a document correcting the published book. And you can see here, I'm very grateful to Stephen Converse, Jonathan Crabtree, and other people. And so his errata, his corrections, he refers to the errors that I pointed out. 3 added to itself times 5 times should be the sum of 5 copies of 3. 5 added to itself 3 times should be the sum of 3 copies of 5. And 12 added to itself 17 times should be, this is the sum of 17 copies of 12. Now, he doesn't use 0, which is not ideal because 0 does simplify mathematics greatly beyond this. So via Brahmagupta, we multiply positives and negatives by either adding to 0 multiple times or subtracting from 0 multiple times. So A multiplied into plus B means A added to 0B times. A multiplied into minus B equals A subtracted from 0B times. So with integral multiplication, A is the adjective describing counts or measures of noun quantities, and B is the adverb describing verb counts of additions or subtractions. Mathematics education professors have not ever gone into this detail because they haven't done a deep dive into nothing. My closing argument: today the words mathematics professors and teachers use neither commute nor compute. The reason is India's original definition of 0 was effectively assassinated by the British Empire, whose elementary foundations denied 0 the status of number and relegated it to a trivial placeholder role. Have a look at your QWERTY keyboard and you'll see 0 is not at the start of number, it just comes on after the number 9. And that goes right back to the times of the Arabic understanding of 0. Now, we know that the British Empire falsely established the nonsense notion that negative quantities are less than positive quantities. We saw how that worked with the inequalities, the absolutely greater and less than. Now, despite this being inconsistent with our shared experience of scientific and physical laws, children balance on a seesaw, or a teeter-totter if you're in North America, because their positive and negative forces are equal and opposite. Integer inequalities are confusing and based on arbitrary assumptions or axioms that need to be updated based on the original definition of 0 as a sum of equal and opposite quantities. It's time mathematics became more intuitive and connected to empirical evidence and the correct understanding of India's 0. So we can look at mathematics without India's symmetric 0. And here I've got color coding for this elementary math matrix for positive and negative 12 and positive and negative 4. So we've got the 4 operations here, and the green means that the lessons taught up to year 7 are relatively easy. The lessons up to year 7 or class 7 in yellow are much harder for children. And believe it or not, no maths professor I have ever met has ever been able to correctly explain positive 12 divided by negative 4. There's just never been an explanation for it. The 2 models that people use, that the professors have come up with, the equal groups and the repeated subtraction models, fail. And yet this is now to be explained to children in less than 20 minutes with pure, perfect intuition. Compare if we had followed India's definition of 0, everything here becomes easy to understand, especially the complicated things no one understands at the moment, like the positive 12 divided by negative 4. So everything becomes simple with Podomatic Bharti maths, which is why it's possible to teach children 4 years more quickly. So, in the High Court of Common Sense and Public Opinion, in the matter of the negligent abuse of power by the aforementioned defendant to suppress, deny and delay the adoption of India's superior zero-based foundations of elementary K to 8 level mathematics between 1522 and 2022, what's your verdict? Are the British guilty or not guilty? Thank you. If you care, please share. This has been Jonathan Crabtree. Thank you so much for watching this. Visit my website. Please give me your feedback. You've been watching The Zero Assassins. Happy 500th birthday, because a new dawn is here. Thank you. Thank you.